Hello, everyone. I know that we still have quite few minutes, like more than 10 minutes. So I just logged in to see if you have any questions in the meantime. Please feel free to drop this in the chat as usual, and I will try to address them as much as I can before we start. When will the last lecture be uploaded? It's going to be uploaded today. I'm in fact processing and uploading it right now in the background. So hopefully by end of this lecture, it should be ready. The spending limit got reached on GitHub. Actually, that's an excellent question. This announcement that I was going to make. But okay, so let me directly address your question and then repeat myself again once we start. So the main thing is don't worry at all about right now about the auto grading in GitHub. Just check your code using the Eclipse. And this is one reason why we have both the GitHub AutoGrader on the repo, in addition to providing these makefiles for you locally to be able to test your stuff, right? So just run your program through Eclipse as usual. You'll be able to see the failing tests as well as the passing ones. And then before the deadline of submitting the lab, we will recharge the GitHub spending limit, which means you will be able to submit. So the main thing is don't worry at all, right? Don't even look into the AutoGrader right now. Just check your code locally and then feel free to either push or wait until you finish the lab and push. It doesn't really matter because the limit does not affect you submitting stuff. And we will handle the AutoGrader in the meantime. Good? Yeah, thanks. Okay, for Salah, don't worry too much about the GitHub AutoGrader for now, because as I was saying a few minutes ago, GitHub AutoGrader has an issue. It reaches the limit, and this shouldn't affect you submitting the lab at all. You can submit, but to check your test cases, you can do this through Eclipse locally as usual. So don't bother looking into GitHub AutoGrader right now. For your question, Michael, so as I said last lecture, generally any question that doesn't take an input, you don't need more than a single test case. So the main thing is if you add any test case for question 1, question 5, they will be in fact redundant. So don't do this if you don't want to. If you want to add them, they will be exactly the same. So it's, yeah. Michael, and also people see spending limit reaches. Yeah, this is what I was, okay, so I will comment on this once we start, such that I make sure everyone is there. Yeah. So yes, Ahmed, do we need to scanf for questions? No scanf at all in any lab. This is a general rule, unless you are asked to do otherwise, because right now all the labs are constructed as functions that also being tested using test cases. So any input you would take from the function as an input parameter. And no printf at all. This is also a note that I made in an announcement, and I just want to make sure that you also get this. Don't print anything, even if you are asked in the lab document to print stuff. The reason for that, you can in fact print locally, right? For you to check, for example, but when you submit, don't print anything for 2 reasons. The first one is this takes more time for GitHub AutoGrader. So it will take a few minutes before you see the check mark, for example. And the second thing is also when we automate internally the grading for the TAs will grade your lab, we don't want to see any other printed messages than the tests, right? In lab 1, this is a question about lab 1. Are we allowed to use math library function like power? Okay, so I would say you can, but you don't need to. So my general recommendation is don't do this. The other thing that you might not be aware of is that using the power function or generally math functions sometimes would require that you add compiler options for GCC, something that you don't need to care about. So Basically, you can if you want. If you face any problem, come to the office hours and let us know. But my recommendation is you don't need that. I get push successfully and I can see changes on my GitHub. However, there is a cross saying auto grading failed. Okay, we'll comment on the auto grader right now. So how can I check if I am right or wrong? So Salah or Joe Yang or anyone, maybe I guess I would say this for the second time and then comment again at the beginning of the lecture. You can simply check whether you are correct or wrong by running the program in Eclipse locally, right? Because Eclipse gives you in the console exactly the same messages that you get from the auto grader, which is like what test cases fail and what is the expected value and actual value for these testing cases and which ones pass, right? So this is how you can test yourself. And forget about the auto grader for now, right? This is something, in fact, auto grader is more for us than for you. So you can do all your lab, do all the checkings you need, submit without even looking into auto grader. Last time and in the tutorial, I was showing you auto grader because it's a different way. It doesn't show you any new information. In fact, all of the information that I showed you in the auto grader are already printed in Eclipse as well. But I wanted to familiarize you with the environment itself. For now, because we have this limit, so don't worry too much, and we will handle this from our side. Can we define our own functions in lab 1? Well, that's a good question. You don't need to. You can if you want. However, if you do this, you have to be careful that you need to pass all the test cases for the functions we give you, right? Question, mine shows all checked failed GitHub Classroom workflow after okay, I will comment about GitHub right now. Again, don't worry about GitHub AutoGrader at all for now. Good? Okay, so let me see what is the time to start. Okay, we still have a couple of minutes, so if you have more questions, let me know. By the way, I already uploaded slides for the lecture. In case that we manage to finish the slides from the previous lecture, and we use the new one, so you already have them on Avenue. You don't need to the power, Salah, for the lab to develop it, right? You don't need even power function for the whole lab. But as I guess I see the answer, I don't see the name, just the email address. You can use the power function, but for this, you need to include the math.h, right? Okay. One comment to make, or maybe I'll wait for also maybe for others to join before I make this comment about the lab. But again, in this remaining minute, let me know if you have further questions. Again, the office hours schedule is exactly as in Lab 0. You have the support and you are highly recommended to use that. Don't wait for the last day to develop your lab and then discover that you have a bunch of problems that no one is there to help you with, right? These labs are designed to take some time. So start early such that if you have any problem, you seek help and then you save yourself a time. I changed the files as we talked about in the office hours, but I still have an X on the GitHub. I will comment, Katie, about the GitHub for now. Okay. Are there any other questions? Because I guess maybe we can start. Okay, so maybe 1 or 2 minutes. I'll take another question if there is any question before I start, just to make sure that if someone is joining. So yeah, feel free to drop in. Maybe I'll take a question or 2 questions before we start. Sandy, I keep getting the permission denied. Sandy, I replied to your email, so please, if you still face this, I guess maybe you didn't have a chance to see my email, but come to the office hours and we can see what's happening. Okay. I can take another question in the remaining minute before I start. I still see people joining. Okay, good. So I guess we can start now. So general two announcements or information about the lab to make sure everyone knows what I'm talking about. The first thing is I sent an announcement and an email to everyone for how to handle the lab one problems. It was mentioned in the announcement or in the email that if you already cloned the repo before I make this announcement, then you need to do some steps. But if you cloned it afterwards, you don't need to do anything. But in fact, it turned out that there are some problems also that appear even if you do the cloning later. So what I advise you to do, if in case you face any problem with the lab, is to follow the steps. These are very simple 2 steps. In fact, I sent 2 files. You just replace them, like it's a make file and the run.h file, replace them, run.shell file. So replace these as instructed into the lab folder, and then make the couple of changes I suggested. It's like 2-3 minutes change, and that's it. This will fix all the problems you face. And then the second thing is with regard to the GitHub autograder, right? Don't bother at all about GitHub autograder right now, right? I guess because many of you submitted multiple times. Like the GitHub Classroom has a budget for the runtime for the autograding, and we reached the limit for this lab. So, but there is no problem at all. Nothing is being affected at all from your side. You can still develop the lab, push as many as you need. It doesn't really matter. But the only thing is that don't look into it autograder and don't bother, right? From your side, how can you check whether your lab or specifically each question is correct? You can simply run the test cases through Eclipse locally, and this will give you the detailed message about the successful questions and the failed test cases and why they fail. So nothing from your side at all is affected by the autograder, so don't worry about it for now, right? Yes, Yan Hao. So if you face a problem in lab one, do the steps, even if you cloned lately, do the steps that I suggested to do, just to be in the safe side, right? Because during the office hours, I saw that there are some problems for some of you, not for everyone, but some problems that arise, and the solution was to, in fact, do the steps that I suggested, even if those students cloned lately. So these 2 things, I just want to make sure they are clear, right? Follow the steps for the announcement, no matter whether you clone lately or not. The second one is don't bother about autograder at all for now. Do exactly what you used to do in Lab 0, submit as you wish, push as many as you can, like the environment will not prevent you to do so. You can check your lab locally, and from our side, we will handle the auto grading and the lab grading and marking, right? Good. This is with regard to the lab. The third announcement, and which is the important one, we have office hours, 4 office hours daily for help you with the lab. Don't wait for the last couple of days. From Lab 0, I have seen at least I don't remember the number, but a significant number of students started developing the lab very late on Friday. This might work for Lab 0 because it's a very simple thing. But in fact, some of them already faced problems and they weren't able to submit. But generally, labs will take time. So if you wait for the last day and you face problems, you might not find the help that you need. So we have 4 office hours daily from 10:30 to 2:30 in addition to the lab session, in addition to my Tuesday office hours. And as I said, I usually drop in office hours of the TAs as well and the lab sessions. So start early. If you face problem, come to the office hours, seek help, and then you will make progress, right? This is the best way to practice. Good. So I hope if there is any other problem with the lab, please drop in these office hours and we can address them. So let's jump into the lectures now. I guess it's enough time for about the lab. When are we releasing lab 2? So labs are usually released. So labs start every 2 weeks on Monday. So usually I release them either Friday or Thursday the week before, right? Yeah, thanks. Okay, so last time we stopped here. Good. For logical operators. So again, what is the big picture? What we have been doing in the last couple of lectures is we started by examples, practical examples. We opened like online GDB together and we wrote programs using functions arrays, header files, declaring variables, loops, all of these things, right? Just to give you a hands-on and get you interested and engaged in programming in C. But we needed to stop, take a pause, and start looking into really what are the rules. For example, we wrote loops, but are there different alternatives or ways of writing loops? Are there tricks? We define variables, but what are the different types in C? So you need this kind of theory background to make sure you understand what is going on. And this is what we have been doing in the previous lecture and previous 2 lectures, in fact, and we are going to continue this in this lecture. So logical operators. In some of the examples, we found that we need, for example, the AND to, or the OR case to merge 2 expressions together or merge 2 conditions together, right? So now we will cover in detail how logical operators work in C. A unary logical operator, or like a logical operator that takes a single operand, is the not or the negation, right? For example, if you have an expression and then you say not this expression, that means you will just negate it. And this will apply to a variable as an expression as well, right? Something to remember from last lecture is that C does not have a Boolean type, right? So we said all the logical conditions evaluate to true or false, but in C, true means 1 and false means 0, right? So in fact, it's an int, right? Good. So let me see how to go. That's interesting. How to change slide then. Oh, it seems. Okay, so I guess I need to fix this. For some reason, it doesn't turn the slide. Okay, so that's interesting. Okay, so I guess maybe I will just share from my laptop then. I was preferring to use my tablet, but things are not as handy. Okay. Okay, let me check if that works. Okay, good. Full screen. And hopefully this should be, okay, good. Okay, we are all learning in these days, so good. So, for example, if you have a non-zero, this is a fundamental thing to understand in C, is that expressions evaluate to end, and like conditional expressions evaluate to end. For example, if you have a non-zero expression and then you take the not, this will have a value of 0 and a type of end, right? And then, for example, if you do not 0, this will be true, which means it's 1, and then it will also have the type of end, right? So let's think together. If I do something like not this kind of decimal point, what do you think would be the type or the value? Now this is not 1 or 0, so what do you think? First of all, what would be the value? Let's see. 0, yeah. Are you still able to see? Okay, 0 and type end. Yes, because any non-zero value is true in C. And that's fundamental to understand. The expression, if it's true, it will evaluate to 1. But you can say any expression that is non-zero and it will be true. So it's not true, which is false. False value is 0 and the type is n. That's correct. The second one is 3 equal 4? That's false. Not false is true. And then true is 1. So the type will be int and the value will be 1. Good. So this was the not or the negation operator, which is a unary one. It takes a single expression. What if we want to concatenate two together? And we have done this in one of the examples in our hands-on programming. So you have two expressions and you are either doing the and or the or of this, right? And this is how you write the and in C, and this is how you write the or. Good?
Sorry, can we combine and or together to form a condition?
Yeah, you can have any, thanks for the question. So you can have any kind of form of complex conditions together, right? So this, you feel free to add, here is the general rule. You have an expression and a logical operator and another expression. But the whole thing is an expression of its own, which means here, if you do this, we say that this is the rule in C, correct? Expression, and for example, and expression, right? But this whole thing on its own is in fact a single expression, right? Which means you can concatenate with another expression that has all types of other operators. So you can have whatever number of conditional or convoluted expressions and conditions together, right? Good. Condition that a character letter is lowercase. What you can do for this, remember that we said the ASCII representation, all the lower, okay, maybe a step back from previous lecture. We said characters are represented as ASCII, like we had the ASCII table, which means they have an end value. If you look into the ASCII table, you would find that all the lowercase letters or the small letters are next to each other. They start from a certain value, which is small a, and they end up at a certain value, which is small z. All the small letters are back to back in that range. So if you want to check if a letter is a small case or a lowercase, what simply you can do is that you check whether this letter is larger than or equal to A and less than or equal to Z. This might sound weird to you, but if you look into it like closely, is this A has a value of int, right? Let's say, I don't remember the value for right now, but say it's like 98, for example. And the letter, if it's a character, it also has an end value. And you are checking whether this end value is larger than or equal to this end value, which makes sense. This is an expression of ends. And then this will evaluate to true or false. And then you add this with another expression to check whether it's limited by the Z one. So it's less than or equal to the Z end value, right? Does this make sense? Okay. So the general rule of and or, and we have seen this before, is that for and, it gives you 1 only if both expressions evaluate to true. Or generally in C, it's non-zero value, right? While for the or, it gives you 0 only if both are false or they have a 0 value, right? Good. Circuit evaluation. So let's look into this example and see what's going on, right? So what I'm defining here is I'm defining 4 variables, 4 end variables. I'm initializing A to 0, B to 1. And then I'm doing something like that. And these are some of the tricks in C. And based on the rules we have covered last lecture and this lecture, let's see how these things work together. First of all, what do you think the value of C would be? Let me see if there are any hints. One, 0, 1, 1, 1, 1, 1. So it seems to be dominant one. Let's see. First of all, once you find an increment or decrement, you need to ask yourself whether this is a post increment or a pre-increment, correct? This is a post increment, right? Which means you do the increment after you do the expression calculation, correct? A is 0, and then B is 1. I don't increment A until I calculate my expression. So that means this will evaluate here, this will evaluate to 0. 0 and anything, which means false and anything is false, right? Because and gives you only true if both are true, which means C will evaluate to 0, right? And then what about, but the end of this statement, you also have A incremented and you have B incremented, correct? Now I go to D, I check, but again, it's a post increment. So I'm taking A value as 1, B value as 2. Both are non-zero, which means it will evaluate to true anyway. So D will be 1. But also I'm incrementing A, so A will be 2. And I'm incrementing B, so B will be 3. Correct? Comma operator, this is not covered, right? So don't worry about this for now. This is rarely used in C and in a very rare condition. So let's not bother about this for now. There are more important things to cover. Why and has higher precedence than plus plus? So it's not higher precedence. It's the thing is plus plus. If it's a post increment from the last lecture, it only get calculated after you evaluate your expression. Correct? This is why it's called post increment. You calculate your expression first and then increment. If maybe, I guess this will also address this point. Let's see, I was writing the expression like that. What if I was saying C equal plus plus A and something like that? This might kind of explain to you something. Here, you do increment A first because it's a pre-increment, which means this expression would have the visibility for A as 1, right? So now this will be 1 and B still not incremented, but B is initially 1 anyway. So C will evaluate to true or 1, correct? This is a main difference between pre-increment and post-increment, as we have seen in the previous lecture, right? It's very important to pay attention to these examples. If you get confused, if I were you, what I would do, just open a compiler, Eclipse, Online GDB, whatever, run different examples, right? For example, start by the examples in the lecture and try to make sense of them, right? Okay, precedence, we already covered this. Yeah, if else, so in some more details, good. So we said if takes a condition, and this condition can be a logical expression, right? So if I'm saying like if half, what do you think? 1/2. This is also something that is important. Do you think the output will be yes or no? Let me see. No, no, yes, no. What do you think? We have more no than yes. Let's see. 1/2. 1 is an int, right? 2 is an int, immediate value of type int. So an int divided by int, that means it's an integer division, correct? Which means if you do an integer division, you only take the correct int value and you truncate the fraction, right? So 1/2, in fact, would give you 0, right? And then here you are saying if 0, which means if false. So in fact, you will get no, right? Correct? What if I do something like this? Oh, it was written here. That's interesting. I didn't pay attention to this, but okay, it's good to discuss anyway. So what about this one? Why you guys froze? Did I get disconnected? I'm still here. Can someone confirm that you still? Okay, good.
Yes.
Thank you so much. So what about this one? Here it says the condition is true, but let's see why, right? We said before, an integer division will only happen if the two operands are ints, right? Now one of them is float, the way you write it, right? So int by float. Recall another rule we said last lecture, which is if you do an expression that has two different types, the wider one will be enforced. So you have an int and a float, and it's a division. So you do a floating division. So this should give you 0.5. 0.5 is a non-zero value, so it evaluates to true in C, and then you will get yes, correct? Okay. Let's see some more examples. I define double as x. If x equals 7, that's for sure no, so you get no, right? But a mistake that this is, I can say, like, this is one of the top 5 mistakes anyone do in programming in C, right? Which is you mix up the equivalence condition checker with the assignment operator. If you forget only a single like equal, this will turn out to be if x equals 7. This, first of all, will be accepted in C. Why it will be accepted in C? Because any expression that does not evaluate to 0 will give you true, right? So what would happen, the compiler, what will do, it will assign x to be equal 7, which means at the end, x will also be equal 7, and this will be true, right? And this will give you yes. While in fact, most of the time you intend to do the checker, not the assignment, right? So always make sure you don't mix up the assignment operator, which is a single equal, with the equivalence checker operator, which is equal, right? Because what would happen in C is that it will consider this expression as always true, right? And you will never reach the else. Good. Yeah, so another good programming practice to prevent this is, instead of doing this, to make sure you didn't forget yourself, start always with the immediate value. Why this is the case? Because if you try the other way around, unintentionally, you cannot have an immediate value in the left-hand side of an expression because it's not a memory storage. You cannot assign x to 7 because 7 is nowhere, right? It's not stored. And then the compiler will give you a syntax error if you mistakenly forget an equal. So if you do this, you will get a syntax error. And it's like guiding the compiler to give you an error in case you forget an equal, right? But that's a programming practice, right? It's not something related to functionality here. Good. A final thing, and I guess we did this before as well in one of the examples. A final thing related to conditional checking is we have if, we have the while and for also take conditions, but we have a compact statement in C. It might not exist in other languages, that what we call conditional operator. From the previous example, I don't recall right now the example we have done. If someone recalls this, maybe like please write me in the chat, but we have done it in one of the examples. So you start by a condition, you check whether this condition is true or not. If it's true, you execute the first condition expression. If it's false, you execute the second expression, right? So if you want to translate this into if, what I would write, if condition, it would be expression 1, and then else, it would be expression 2, right? So it's like a compact way of writing an if-else statement. So one example here is how to assign a minimum of 2 variables into another one. So you'd say, maybe I have a minimum variable called min. If x is larger than y, I would take y, assign it to min. Otherwise, I would assign min to be equal x, right? Okay. Here, some examples that says you can, in fact, have a very complex way of writing this conditional operator. Generally, it's not a good programming practice to have complex conditions using conditional operator. If it's simple, that's great. If it's not simple, you are recommended to use if condition because it's easy to debug, easy for you to reason about, right? But let's look into this together to see what's going on. The first one is correct because here you have a condition saying if greater is greater than or equal to 60, so this is an expression. If it's true, you do something. If it's false, you do something else. One thing about this expression is the first expression does not have a semicolon. It just has these 2 colons, right? So it's, if you do this, it will be a syntax error. It's wrong, right? Dangling else. But let me see if you have questions before I jump into the if else and dangling ones. What if you did if x equals, Thomas, this is your question, if x equals 0, then x will be assigned 0 and the condition also will be true. That's in fact an excellent question. Why? Because you are not doing the condition on the value of x. You are doing the condition on the value of the expression, but the assignment already happened. So it will always evaluate to true, right? compress 2,000 lines of code into one. Don't do this, right? Big performance, I'm not sure if I get what you mean, but it's not good for readability anyway. Okay, thanks. So what we mean by dangling is sometimes if you write a code like this, you might think that this else is related to this F, but that's not true because the compiler, remember, think in the compiler mindset. The compiler executes line by line, right? If the compiler finds an F, it will keep looking into an else, right? So here, until it finds another F. As a compiler, I'll start evaluating this F and then go to the next line. Once I find another F, I will forget about the else of this one. It will not be there unless I open a bracket. So what we want to say, even if you write it like that, this else will be associated to the last F before it, right? If you want to associate this else to the original F, you can do something like that. F, I guess I have a, yeah, you can do something like this. You can open a bracket here, which means all whatever is inside is related to this body, and then the else is outside. So this else will be related to the first one. So here, A is equivalent to B, and it's not equivalent to C. And this is called usually, it's a mistake that is usually called dangling else, which means you might mean an else associated to a certain F, but it will be get associated to another F unintentionally. Good. Okay, so break statements and switch statements, something that we didn't touch on. Some of you already mentioned this example before when we were doing, let me try to remember. So when we were reading something from the user and we said, if it's one, you just exit your code, right? And we said, we don't need to continue reading from the user if this was correct. Or another thing was you check whether your array or the numbers entered are sorted or not. So once you discover a single instance where the condition is not met and the array is not sorted, you just break. You don't need to wait for doing the remaining operations. So break, the general rule for break is you just exit out of a certain block of code, which is usually a for loop or a while loop or a do while loop, right? So let's see an example. Okay, I will not say continue for now, but let's look into the break example. And it's very similar to what we have done before, the odd even case. So here, what I'm doing is say, okay, once you discover that there is an even number, you break. Once you break, everything else remaining in the loop iteration, in the current iteration, will not get executed, right? But also, you don't go back and continue the iteration. So you exit the code completely, like the block of code completely, and then you print done. So let's iterate one by one what would happen if I is starting from 0. So if I starting from 0, is 0 is less than 4? Yes, that's true. 0 mod 2 is 0, that's true. Then you break. Then here you would get done. Which means what? Means you didn't execute this line at all, right? On the other hand, if you want at least to print once, or at least to skip one iteration of the loop and continue the remaining iterations, you use continue, right? I guess this also, you guys cover this in Python. But the main rule is for continue, you skip the remaining iteration and then you go back and check the other ones. If my functionality, if my intention from this code is to only print the odd numbers, then if you do this break, you might end up, if you start with an even number, you might end up not printing anything at all, right? But here, if I continue, let's see if with the continue case to understand how it works. I start from 0. If 0 divided by 0 is true, you continue, then you skip the print, and then you go next. You incremented I already, so 1 is less, that's correct. 1 mod 2 is 1, so you don't hit in this condition is not true, so you don't continue, then you print 1, right? And then 2 will not get printed, 3 will get printed, and then 4 will not get printed. So you print 1 and 3, you print the odd numbers, right? How did this happen is because if this condition is true, you hit the continue line, which means skip the remaining lines of code of this iteration, but go back and continue the remaining iterations, right? This makes sense? Let's see.
Sir, so in this while statement, when you're doing I++ is less than 4, so first it's going to check 0 is less than 4, and then it's going to add 1 to I, right?
Yes, that's correct.
Okay, so then when you get to the if statement, it's going to check 1 modulus 2.
I see. Okay, I see your point. So this depends on, okay, that's a good question. To be honest, when trying this before, I found two different instances based on the compiler. The first one is the post increment will get incremented after this expression. So once it enters the loop, happens what you are saying, right? Which is I would be, for example, 1, right? In another compiler, the post increment happens after the whole iteration. So because one block of code in while loop or for loop can be considered as a single block of code, so a single expression. So this get incremented at the end of the iteration, not at the end of the expression evaluation. Do you see my point? So it depends. So what you are saying is correct, but I experimented both using different compilers, and two different results came out, right? But what you are saying is correct, is that post increment happens after you evaluate your expression, and this is my expression, which means once I enter here, I should be 1, right? This is what you are saying. Did I address your question?
Yeah, okay, thank you.
Okay, but I like this comment, it's a good one, thanks. Do results Harun? That's okay. Generally, no. In 99% of cases, no. But yes, in some cases, results can vary with compiler, because compilers, based on which versions you have and which compiler you have, they assume a certain standard of C. C has different standards, right? And some of the standards allow things that don't exist in others. For example, some of the most recent standards in C, they have, in fact, a Boolean type, right? And you can do this in a certain way. So I don't want to confuse you, but generally, no, compilers does not change results unless there are some special cases for that. If you wanted to break just the if statement and not the while condition, how would you do this? Okay, that's an excellent question. Jack, you don't. There is no way of doing this. And this is one of the things that you need to understand about break and continue. It applies to loops and switch case, not for if. So you don't break an if, but you remain in the loop. So this doesn't happen, right? Does I increment before or after checking the condition, Nicole? It's after, because it's supposed to increment, right? Question, is it boogers if we just make sure we have an else and break for every dangling else? I would say actually the right way of doing this, what I said last time, which is a good programming practice, you always open brackets for every if, else, while, for, even if it's a single statement. This is the safest way of doing it. What about nested for loops? Okay, that's also a good question, Mohammed. So I guess your question is, if I do a continue or a break in a nested for loop, what will happen, right? So you only break the loop that you are inside. For example, if you have, I don't know, like you can have as many nested loops as you wish. You only break the one that you are inside. So it's the most internal one, right? Okay, that was a good question. I'm not sure if we have an example for this here. Okay. So let's see. What we are doing here is different variations of doing different things to make sure we understand the break and the continue, right? If I do this block of code, I start I by 3 and j would be 1. And then I'm checking if j is less than 5. So what I would do is 1 to 5, and I'm just printing stars. So simply you just get 5 stars, right? Here, if I try the break statement, each time, instead of printing directly, I'm checking whether j is equal to 3 or not, because I is equal to 3, right? And if so, I break. So what would happen is start j equal 1, so not equal 3, so I print. 2, I also print. at 3, I break. But break means exit this iteration and every subsequent iteration, so I only print twice for the j equal 1 and 2, right? On the other hand, if I come to the continue, what would happen is you print for 1, j equal 1, j equal 2. When you come to j equal 3, this condition will be true. So you continue, which means skip this one, but you continue by j equal 4, and you print, and then 5. So you see the difference? Here you printed 5 stars. Here you only printed twice, because once you hit the condition, which is j equal 3, you skip everything. Here you only skip the value where j equal 3, but you continue the remaining iterations. Hopefully this makes it clear, if you guys do remember from the Python case. That's correct. If you had a pre-increment, I guess, Dan, you are talking about the previous slide. If you do a pre-increment, then you increment before checking the condition. That's correct. Okay, so this is another example. So I will leave you for leave this for you to check offline as part of your study for this lecture. But maybe one comment. You know what? Maybe I should cover because of the nested question that Mohammed had. Okay, so here we have a nested 4, right? Let's see what happens. I start j equal 1, and then I is equal 1. Is j equal I? Oh, initially that's correct, right? Because 1 equal 1. Then you break. Break means I'm just exiting this loop, right? But then you go back to the other loop. I will be 2, right? And then you come here, you start executing this from the beginning, j will be 1. So if j equal, so is 1 equal 2, that's wrong, then you basically print a star, and this is the iteration of I equal 2. You print a single star, and then you have a new line. And then once you increment j from 1 to 2, it will be equal, then you skip. You go to I equal 3. You start by j equal 1, so 1 is not equal 3, 2 is not equal 3, and once you hit 3, you'll stop. And then I equal 4, you will 1, 2, 3, and then 4 you will stop, and then I equal 5, you will have something like that. So what you basically do, and then I equal 1, you have a new line, right? So what you basically do is you only skip the internal loop. Hopefully this clarifies this thing. If I do a continue, let's see what happens. In case I equal 1, yes, initially it equals, so I continue, so I skip this. Skip this means you continue j equal 2. So you would 2, 3, and in fact you do this until 10, which means you have 9 stars, right? From 2 to 10, that's correct. And then for I equal 2, you would also have 9 stars, because you print 1, you skip 2, and then you do to 10, the same thing. So you would end up having 5 lines of 9 stars, right? You can try this yourself if you want. So let me remove this to show you the outcome. Is there any question with regard to this? So the general rule is the continue statement and the break statement only applies to the internal loop in case you have nested loops, right? Okay. If else we covered previously, and you can have as many nested if else as you want. You are already doing this in lab 1 for the student grades. So it should be fine. Okay, you can write this in different ways. That's simple. That's okay. What I want to cover is the switch statement, right? Because this is we didn't touch at all before. Yes, you covered in Python, but let's see what happens in C. So switch, it's similar to while and for. While can do exactly the same functionality as for can. The same thing for switch and F. Switch can do the exact same functionality for F, but both of them have different use cases. For switch, the best use case is that you know you have some kind of an integer expression and you have different cases. A typical case is the one, in fact, that you have in the lab, which is you have a student grade, which is a floating point representation, and then you have different cases. Condition 1, is it like above 90? Condition 2, is it between 80 and 90, 70, 80? So you have different cases. And based on each case, you evaluate a certain expression. At the end, you have a default, which is in your lab. The default is to print -1 or -1 if the grade is not a meaningful one between 0 and 100, right? Okay, so an example would be, assume I take a character as a break, as a grade, and then this can be either A, B, C, D, and I want to translate this into a numerical grade, right? Similar to the example of the lab, as I said. One thing just to understand is you need, after each case in switch, to have a break statement, because otherwise things would remain checked, right? And including the default one. Assume, for example, a student had an A and you didn't have this break. What would happen is you would print 85 to 100, but then, okay, it will not satisfy this condition. It will not satisfy this because it's already above 85, but it will print the default one. So you will also get something like 60 to 69. So as we said, a good programming brackets in F is to always open brackets. A good programming brackets in switch is to have a break statement after each case, unless you intentionally remove some of these, okay? Here, I just give you an example of what I was saying. Assume that the grade is B, so you get 70, 84, this one, case C, so it will not in fact be that, but you get 60 to 96, that's correct, right? Oh, okay, that's also, yeah, you should in fact get these two only. Why it prints that? Because it's not D. You shouldn't get that, right? Okay, so let's, yeah, so what if I skip the break? Or for example, if I want to combine two conditions together, like if you have an F, combine an expression and an expression. So you can do this by combining cases together. For example, you want to say, if I have a grade as a capital A or a small a, then it will be just A or A, right? So that means this statement will be printed if case A is correct or case A is correct. This is how you combine case statements together, right? So it's or. So if any of them is satisfied, you just print that, right?
Can you use the or symbol instead?
So in case, okay, that's a good question. In case, don't use any Boolean expressions. So you don't combine, because case is expected to take an integer value or a character value, for example. Like it takes a certain immediate value, right? If you have combined or and statements, then it's better to use the F, right? The F condition.
Okay.
So the typical use case of a switch is a very simple scenario where you have a variable that gets different values, and you know these values, and then you do a case switch across all of the values, right? But for example, you say, what if the student gets something between 80 and 60, and for example, he took class A. So you have something that is combining multiple conditions. In this case, F is better, right? Okay. The two case labels have the same value. Yeah. So one of the things is, in case each, because this is in the compiler, it's looked as different. It's like an FL. So it's either this will happen or this will happen. If both has the same value, then the compiler will not be able to execute both, but it has to execute both. So it's kind of a syntax error. One question on the side, why these two have the same value? Because 65 is the integer ASCII representation of A, right? So it's like the compiler will see them as a repeated case, which is not allowed in C. Okay. So we also did printf scanf in the first couple of lectures, and let's see some of, we use specifiers, but let's see some of the detailed examples about this. So we used the percentage D for the int, and we also use the percentage C for characters, and we have also used the float one. And in fact, we also used the double one, which is L float or long float, correct? What if I want to combine? So this is a general rule. So the good thing about printf statements in C is you can combine different variables, and the placeholders will work for you to say exactly where you want to place these variables into the placeholders or the places of the specifiers, right? For example, this printf statement would give you sum equal. This is a placeholder. Look into the first variable. 2 plus 3 is an expression. Evaluate it. It evaluates to 5. And this will give you a sum of 5. And then you take the average. Sorry, this will give you the average of this expression, which I guess is going to be 2.5, right? Good. All of this is just details. Let's look into how I want to format some output. So first of all, we know that the first input parameter in printf is the string itself that you want to print, right? And everything is getting printed as is, like as a string, except the placeholders, right? For example, for this thing, if A is 7 and B is 5, you don't expect to see 7, 5, right? Or 7 plus 5. That's wrong, right? What you are expecting to get is A plus B equal, and then this is a placeholder. Look into the first variable, evaluate it to 7.5, then comma, and then C equal, and then C is just K, right? So you format your output using this string statement, right? And you only evaluate expressions for the placeholders. Good. Okay, what else we want to cover? Yeah, some other interesting thing in printf is what if I want to format it to print it using a certain width? What I mean by this, if I just simply print 34 like that, you will get 34, right? But what if you want to take certain spaces or certain digits for the 34? So what you would get is, here you say, I want to print this decimal value or integer value, but it should take 4 characters in the screen, right? 34 is taking 2, so it will give you first 2 empty spaces, and then 34 is printed. And then also this is a character, and it should take 5. Character is a single, like digit, single space. So you print 4 spaces and then the digit itself. That's how you can format. Using these numbers, you can format how many spaces, for example, you want across different variables in your printed output, right? Another thing, so this is called field width, like how each parameter in your printf list, how many digits or how many spaces in the screen it should take. On the other hand, if I want to not just remove or have white spaces here, I want to have a certain precision. For example, it's a floating point or double representation. How to print my variable? So here it says that the default is 6. This is why if you go back to this example here, you'll find that it's printed as 6 floating point digits by default because it's float, right? And this is your what we call your precision, right? For example, you want to print this number as here. So, and this is important to understand, right? Here you say, I want the total number of spaces that is taken by this. Sorry, is there a question? Oh, I guess this is the lecture. You guys hear another voice than mine or no? Okay. Just give me a second. I guess I was processing the previous lecture. Okay, that's interesting because I was hearing my voice in the background and this turned out to be the previous lecture finished processing. Okay, let me go back here. Good. So, just go back to full screen. Okay, hopefully you are able to see. Can you please confirm? Can you see my screen? Yeah, okay, time is over, but I guess I would only take a couple of minutes. So what I was saying, okay. Precision, because that might sound a little bit complex to understand. So here, I specify two things. The first one is how many total spaces or digits on the screen I would consume for this variable. And the second one is how many precision points after the decimal point I would like. Let's take the second one, it's the easiest one. So I would say I want the precision to be only 3. This is why here you find this being rounded into the 3 digits only, right? 237. Good. Then what is this 8? This 8 is the total number of digits the whole number takes. If you already consumed 3 by the decimal points, then you have remaining 5. This is why 1, 2, 3, 4, and the dot is the 5. So you have a total of 8 digits, and the fraction itself takes 3 digits. Is that clear? Another example here is I just didn't specify how many total digits I would need, but I said I want the precision to be only 2 decimal points. And then this is how you just remove this one and you round it up to like 238 to be 24, right? Is that clear? Okay, this is also saying that character, that's okay. Scanf, we have already tried this before. Okay, I would say, let me see. Maybe there is something else that we would like to look at. Yeah, that might be interesting. Okay, let's look into this. And this is the last thing I am going to conclude with. I'm having a scanf, which means I'm reading something from the screen. And this is going to take input into 4 different variables, right? The first one is supposed to be int. This is why the specifier is D. The second one is long float, which is double, character, character, right? And then I'm entering these as inputs. Good. So let's see what different variables would take. The first one is the integer one would take this. That's clear. The second one is your long float is going to take your decimal float, which is this one. The thing that you might get surprised with is why the third one didn't take the G and the last one took the F, right? And the reason for this is you said, I want my third variable to be character, and a space is in fact a character in C, right? So once you find the space, you read it as character, and this is how variable 3 is taking the space. And then after you read this one, you move your pointer to the second variable, or in this case, the last one, the fourth variable. And then the fourth variable takes a character as well. And the direct character after the space is the G. This is how the fourth one takes the G. So you need to understand that characters, like things like space or new line or tab, are valid characters in C, which means if you don't pay attention to the format of your input, you will read them and they will create, you might be expecting G to be your V3, but it will take the space. Good? Okay, so by this I conclude, and I will remain as usual for like few minutes to take questions, but you are free to go if you would like. Thanks everyone.
Can I ask you a question about the switch case example?
Go ahead, Yunhao. Do you know which, do you want me to go back to the slide itself?
Yeah, a little bit.
Okay, let me see. Is this one or which one of them?
Yeah, this one.
Okay.
I was wondering why, like when you are not putting those break in this statement,
yeah,
and you input for B, why it also runs the statement of C and D? Like it only match with the B, right?
The C will not be printed, that's correct. And the D will not be printed. What I was saying is that the default, though, will be printed. right? If you forgot the break.
Because if you put, what I'm saying is if you don't put a break,
Yeah.
like, can you go to the next
I guess you're talking
slide?
about this one.
Yeah.
Right.
Like, I don't know why it give the output of 60 to 69 and so on. Like, those are the cases of C and D, right?
Okay, I see your question. So here is the clarification, right?
Mm-hmm.
So the way switch works is you keep checking your cases one by one. Once you hit a case that its condition is true, which is the case, for example, for B,
Mm-hmm.
it executes it, and it executes the whole switch statement until it hit a break statement, right? So B will be true, and everything else by default will be true, right? Because it will not even check their condition, right? Maybe I didn't clarify this in while I was explaining it, right? In detail. This might have confused you. So I thank you for the question, but I hope it's clear now.
Yeah, that makes sense.
Okay. So as I said, the recommendation is you always put a break if you want only the statements of this case to be executed and nothing else. Okay. This makes sense?
Yeah, it does. Thank you.
Thanks. So let me check the chat for other questions. Where did the F come from? Okay. I will go into that. Okay, I guess you are referring to the example we have been covering. So let me go quickly into this one. Here. Good. I'm not sure what F you mean, but we didn't read. So we are okay. This is taken as an input because this is scanf, not a printf, right? So we provided this as an input, but F is not get assigned to any variable because you are only looking for 4 variables, and the 4th one took the G, right? I hope this answers your question, Trevor. So let me know if you still have confusion.
Yeah, no, that makes sense. It makes sense.
Perfect, thanks. Are this lecture going to be posted and also the previous one? Yes, the previous one already finished processing while we were in the lecture, and I will upload it once we are done. And this one as well, hopefully today. Where did they come from? Steven. I guess Steven also. I guess this is exactly Trevor's question. I hope I'm already answered that. Muhammad name. Someone inputted it. The user. Okay. Question. On slide 69. Let me see. Now I recall what you are saying. It's about the if else thing. Okay, so let me go to 69. I guess it's this one. I don't see the number, but hopefully it's this one. Is it the case? Let me see. Let me exit full screen. And 16, no, it's not this one. 69 is this one. Oh, I'm not sure which one, to be honest. So if it's this one, let me know. I didn't receive the email, Sandy. Okay, I'll check that, Sandy, and please just drop in office hours and we can look into it together. For the lab one, my code for question works when I run it outside the lab environment, but gives me the wrong result in the lab environment. What could be the reason? Okay, when you say works, you should identify what really you mean by works. Works means it combines with no errors, but when you feed some inputs, it doesn't give you the expected output, because the whole point about the lab environment testing, I believe you are referring to the test cases, is to stress different corner cases in the question. So maybe this is a way to check Har Sahib, and if still you are confused a little bit, so maybe come to office hours and we can look into it together. question for the lab. You said to change something in the test cases for question 6, but what I already have is for int equal. Yeah, no, that's not correct, Abigail. This is exactly what you need to change. As instructed in the announcement, you need to move the int I declaration outside the for. The reason for this is some compilers in C, again, this is one of the things that some compilers accept, some don't, is based on the C version you are using. Declaring variables inside the for initialization expression might not be accepted. Thanks, Zahan. Bye-bye. Mohammed, why does the space before 4.5.8 not give an error in the last example? Let me see. I guess you are referring to the one that this one, okay. I see, okay, that's a good question, Mohammed. And the reason for this is the second variable, which is this one, the LF specifier, is expecting a double, right? But a space is not a double, so it just skips it. The reason that the third one didn't do this is the third one was expecting a character, and the space is a character. This is how it takes it, right? This is a difference between V3 and V2. If expression is false, so there is nothing print in B, but it prints statement 2. So why are A and B equal? I'm not sure, Ziaukun, which slide are you referring to? So please let me know. If you can clarify your question, I will try to address it. Alan, so we should declare the I outside the for loop. That's correct. This is, if you look into my announcement, you already have detailed instruction of what you need to do, Alan, for that. Nice. Okay, are there any other questions? Okay, thanks everyone. Yeah, see you on Friday and hopefully in office hours in case you have questions for lab 1. Have a great day. Bye-bye.
One second.
Yeah, go ahead.
So for exactly this page, did
Okay.
you just put a tab for the blue word version, like between the GF and 45.8?
Here, a tab?
No, the bottom one. Did you put a tab over there?
Oh, okay. So we didn't come in. Okay, that's a good question. Let's see. We didn't discuss this yet, but maybe we'll look into it together. So let's see. Include a white space in front of the character. I see. Okay. No, that's a good question. So what you mean here?
Yeah.
It doesn't really. Okay. We just included multiple white spaces, not a tab, right? But the main point of this is how to fix this problem, right? How to instruct that V3 should take the G, and if there are any spaces, it ignores that. And the key point here is before the character that is the specifier of V3, you just put a space, which means any white space here you just ignore, right?
I see. So you include, like it just ignore all the white space between it.
Yes.
I see. So if you put other characters such as D or E, does it also dismiss those D and E?
For example, you mean if you put D here?
No, like before the percentage sign.
I'm not sure if I get what you mean.
Like
I see what you mean. Okay, yeah, that's okay. That's an excellent question. Let me think. Yes, if you put, for example, okay. So, but okay, you are not recommended to do so, right? But
yeah,
yes.
I'm just asking.
Yeah, that's correct. If you put anything, because why this is the case? Because it's like the format that the user will input, right? So, for example, you say X, Y, Z, and then B. What is B? There is no B specifier. D, right? Something like this. This means you are expecting the user to input X, Y, Z, and then a number. So, which means you just ignore the X, Y, Z and specify the placeholder into the variable. The general rule is variables only take the placeholder values. Anything other than this, it just doesn't get propagated into the variables, right? So if you put anything, as you said here, yes, it will just be ignored, right?
I see.
Yeah, that's a good question.
Thank you.
Yeah, thanks. Okay, good. So let me just finally look into the chat. Can take a tab as a, yes, tab also is a character, Alan. New line is a character. I guess in one of the slides in the previous lecture, we went through some of the characters that are of regular expressions, like tab, new line, space. There are multiples of these. Do we all receive an email about the lab one? Yes, I received I sent an email to everyone about lab one, but I usually do this through Avenue list. So you should find this somehow on your Avenue mail if you didn't get it in your email. But also the email is just exactly what I had in the announcement. I just wanted to make sure that everyone sees it. So if you already know the announcement on the course web page on Avenue, you don't even need to care about the email. Good. Okay. Thanks everyone, and see you all later then. Bye bye.